Hi everyone, this is part 2 of exercise 4 star when working with negative and fractional indices, and I'm going to go through numbers 17 to 24 in this video. Right, so for number 17 it looks horrible, but in fact if you look at it closely and you just take it step by step, it's actually pretty straightforward. So what it is, it's a simple raising of powers. So for example, if you have x to the power of a raised to the power of b, you know that you need to multiply the indices with one another. That's the rule of indices, right? So for number 17, you've got a bracket inside a bracket, a power raised to a power. Okay, so this is the simplified version of exactly what you are supposed to do there. Inside the bracket, we've got a 5 over 7 to the power of minus 2 over 3. And if we want to remove that negative 3 at the top, we are simply going to multiply negative 3 over 1 with the other fraction. Right, so we're going to get 5 over 7 raised to minus 2 times minus 3 gives us a positive 6, and 3 times 1 gives us 3. So 6 divided by 3 gives us 2. And now all we do is we simply multiply it out. 5 squared is 25, and 7 squared is 49. So your answer for number 17, 25 over 49. Easy, straightforward, don't overcomplicate it. Just take it step by step. Okay, number 18. Again, take it step by step. You've got 7 to the power of negative 2 times 7 to the power of negative 3 over 7 to the power of negative 5. We want to get rid of all these negative indices. So I'm going to take this 7 to the power of negative 5 to the top, this 7 to the power of negative 2 to the bottom, and that 7 to the power of negative 3 to the bottom. So now we have perfect positive indices. Now we can simplify it by saying 7 to the power of 5. When we multiply base numbers that are the same, we add the indices. So we get 7 to the power of 5. Now we see that the top in the numerator is the same as the bottom in the denominator, so our answer would simply be 1. Right. For number 19, we've got 4 over 25 raised to the power of negative a half times 8 over 27 raised to the power of 1 over 3. First, let's get rid of this negative 1 by simply flipping everything that's inside the bracket. We flip the fraction, and then our negative indice becomes a positive 1, times, and this one stays exactly the same. We can, however, take the cube root of everything, because that is what that negative or that fractional indice indicates, is simply that. The same on this side. We're going to take this 1 over 2, and we're going to take the square root of 25 over the square root of 4 times the cube root of 8 is 2, and the cube root of 27 is 3. Right, so now I'm just carrying on this side. We've got the square root of 25 is 5, the square root of 4 is 2, times that 2 over 3. 5 times 2 gives us 10. 2 times 3 gives us 6. So we've got 10 over 6 as our answer for number 19. We can, of course, if you want, simplify it to just divide both sides, or both the top and the bottom, with 2. So you have 5 over 3. But 10 over 6 is just fine for this instance. Right. So for number 20, we've got 27 over 125 to the power of negative 2 over 3 divided by 81 over 64 to the power of negative a half. So my first step would be is to make all the negative indices positive ones. Right, to make this a positive one, I'm going to simply flip it. So 125 over 27 gives us 2 over 3. And divided by the same here, I'm going to flip it. 64 over 81 gives me that. Right, now I'm getting rid of the fractions, and I'm getting rid of the fractions by taking the cube root of 125 squared, and I'm taking the cube root of 27 squared, and that's going to be divided by the cube root of 64 divided by the cube root of, oh no, sorry, not the cube root, the square root of 81. Okay, I'm just carrying on this side again. So if you type that into your calculator, you're going to get 25 over 9. And on this side, and on this side you're going to get a divide by 8 over 9. Right, now to multiply fractions with one another, we employ K of C. We keep the first fraction, we flip the second fraction, we change the sign. And 25 times 9 and 9 times 8, if we simplify that, our answer will simply be 25 over 8. That is our answer for number 20, 25 over 8. Okay, then we move on to number 21. Number 21 is where you have to solve x. So you're going to get 4 over 5 raised to the power of x is equal to 25 over 16. Please be aware that when we want to solve x, we need the base numbers to be the same. So what I'm going to do in this instance, I'm going to take the square root of both sides to get this one in a smaller possible fraction like this. So I'm going to take the square root of both sides. Remember, what I do on the one side, I have to do on the other side. And now I'm going to simplify this inverse operations. I'm going to keep whatever is inside the bracket the same, right? But the square root becomes a power of a half, and the x stays there, right? The square root of 25 is 5, and the square root of 16 is 4. So now we're almost there. They're almost similar. The only thing we can do is if we flip this fraction, if we make this a 5 over 4, the only thing that's going to change is we're going to add a negative at the top there. And now we have the same base numbers. So we can say that minus a half x is the same as 1. We want to have x alone, so I'm going to multiply both sides with a negative 2. And a negative half times a negative 2 just gives us x, and 1 times negative 2 gives me negative 2. So x is negative 2 for number 21. Remember, the base numbers must be the same before you can do anything with them. Right. For number 22, we're going to use a similar method. We're going to say 49 over 64 to the power of x is equal to 8 over 7. Right. Now, if instead of squaring both sides, which you can do, you can also raise these powers to 2. So you can basically square both sides with 2. Right? That means that we're going to get 49 over 64 raised to the power of 2x. And on this side, we're going to have 64 over 49. Now our base numbers are almost the same. The only difference is we need to flip them. So instead of flipping this one, I'm going to flip the second one just to show you that it is possible either way. So I'm going to keep this one 49 over 64 raised to the power of 2x, but I'm going to flip this one to be 49 over 64, but then it's going to be to a negative 1 power. Then, because our base numbers are the same, we are not eliminating them. We are simply disregarding them to solve the value of x. So then we can say 2x is equal to negative 1, and we divide both sides with 2 so that we can get x alone as negative a half. Just to show you that you can take the square root or you can square both sides, whichever way is easiest for you. Right, so this would then be the answer for number 22. X is equal to minus a half. Okay, moving on to number 23. We have the cube root of 5 raised to the power of 4, and that is equal to 25x. Okay, so first of all, I would get rid of the cube root by giving this a fractional indice of 4 over 3. On this side, I would take the 25 to 5 square. 25 is equal to 5 square, and just leave the x because it is a raising of a power. Because the base numbers are the same, I can then say 2x is equal to 4 over 3, right? Then I divide both sides with 2. So when I divide 4 divided by 3 divided by 2, I employ KFC again. 4 over 3, keep the first one, flip the second one, change the sign. So 1 times 4 is 4 over 6, and if I simplify that, I get 2 over 3. Right, so that means that x is indeed 2 over 3. This is the answer for number 23. Okay, number 24 is very similar in nature. We've got 1 over 8 raised to the power of 12 is equal to 16x. Okay, first of all, I would flip this fraction just so that I don't have to work with a fraction. I can work with a normal whole number. So I'm going to say 8 inside the bracket raised to the power of negative 12 will give me 16x. Now, how is it possible that I can get these two base numbers the same? Well, they can both be reduced to a base number of 2, because 8 is 2 to the power of 3 times negative 12. And on this side, I can say 2 to the power of 4 is 16 times x. So the base numbers are the same, so I can therefore say 4x is equal to negative 36. That 3 times negative 12 will give me negative 36. Then I divide both sides with 4, and therefore x is equal to negative 9. And that is the answer for number 24. The last number in this exercise, number 25, is 8 raised to the power of negative 8 over 3, and that is set equal to 1 over 4 raised to the power of x. So again, I would get rid of this fraction and just simply say that 4 to the power of x is the same as 8 to minus 8 over 3. I would like both of these base numbers to be the same, so I'm choosing 2 as my base number. So 2 to the power of 3 times 8 over 3, negative 8 over 3, is equal to 2 to the power of 2, which is 4x. Because our base numbers are the same, I can disregard them momentarily and therefore say 2x is equal to 3 times negative 8 is negative 24 over 3. So 2x is equal to negative 8. I divide both sides with 2, And my answer is x is equal to -4. That is the answer for number 25. And this is a typical GCSE exam question.